ETL stands for extract, transform, and load, and it's one of the most common workflows in data science. You take raw data, you clean it up, and then you get it ready for analysis or machine learning. In this video, I'll walk you through a complete ETL pipeline using the Titanic survivor dataset, step by step in Python using pandas. So our task in this video is to prepare the Titanic dataset for being used on a machine learning algorithm that would predict survival. So in order to predict the survival, we'll need all the other data in the dataset. A note here is that machine learning algorithms cannot read text, they need numbers. So we're gonna have to do some kind of reformatting or encoding. So the steps that we're gonna take is first to do the extraction, to get the data from GitHub. Second, to transform, to filter out the important rows and add new ones. And third, to load, to save the data frame in a CSV file locally, ready for machine learning. So let's get started with the first step. What we do is we extract. So we get the URL. It can also come from a database or cloud. So there's several ways of importing data. Right now, we're gonna just import the data from a GitHub repo, but you can also connect to a database or you can also connect to the cloud. In this case, the simplest way is to just use a file directly from GitHub. So what I've done is I've set the URL to the GitHub user content file, and this is different from only the GitHub user. So that's for navigating to the site, but this prefix makes it so that we're targeting only the raw files. So we combine this with the user and its repo. So the user is called Data Science Dojo, the repo is called Datasets, and the file is called master, and the file is called Titanic CSV. So if we click this, we'll get a view of what the file looks like. So let's load this into our data frame. So let's create a data frame called dfraw for just the raw data, because we're going to process it really soon. So pd.readcsv, and then with URL. And just to look at it, we're going to print the head of the new data frame. We're going to use this. Let's have a look. We see all the different columns that we have in the dataset. So the first 5 rows, we have passenger ID, which goes from 1 to the number of passengers on board the Titanic, survived, if they survived or not, passenger class, P class, which is which ticket class they had. So there were high-end tickets, middle class, and lower class. And this is a kind of a proxy for socioeconomic status. We also have the name. That's kind of hard to interpret for a machine learning model. We have the sex, which is in male or female, age, and spouse. So this is the amount of siblings and spouses that this person had on board the Titanic with them. So it's kind of a proxy for family size. Then we had parts, which is parents and children on board. So if you combine these two, you get the family size that the person belongs to. Then we have the ticket, which is pretty hard to interpret. We also have the fare, which is how many dollars they paid to get on the Titanic. We also have the cabin. This has a lot of missing values, around 70% are missing. It does say which deck the users were in. So C85, that's on deck C, and room number 85. Now we have embarked, which is just to say which city the person embarked in. So we have C for Cherbourg in France, and we have S for Southampton in England, and also Q further down for Queenstown in Ireland. And most people embarked in Southampton. Let's move on to the transform. So we're gonna do 4 things in the transform step. So we're gonna select the relevant columns. So we don't need all of these columns. We're also gonna drop the missing values. So any row that has missing values, we're going to drop from the relevant columns, that is. We're also going to encode sex to numeric. So a machine learning model can't read male and female and understand the difference between them. So we're going to have to do a classifier or a number that represents it. So female will be 0 and male will be 1. We're also going to add a new age-fare ratio just to experiment. And I'll show you how to do this. So what we do first is we make a new data frame out of the raw one with only the features that we want. So we're going to be including the survived feature. We're also going to include the P class, because survived we need for the classification, the ticket class for first class, second class, third class. That's a good indication of socioeconomic status, and that might help us do the prediction. We're also going to get sex. We're also going to get age, and we're also going to get fare. And now we just get a copy of these, copy. There we go. So data frame is now a copy of the raw data frame with only these features. Now we're going to drop the missing values from the data frame. So we're going to use df.dropNA and then in place equals true. So what this row does is basically it removes all the rows with missing values from the data frame permanently. So we don't create a copy where we implement these changes, but we do it directly on the data frame. Move on to encoding the sex to numeric. So we're going to target the sex. We're going to create a new row called sex encoded, and that's going to be equal to data frame of sex dot map, which we can use like this, and then we basically just make it so that the male ones, they are turned to 0 and female are turned to 1. So this takes all the male columns in the original and turns it into 0 for this column, and all the female in this column and turns it into a 1 in this column. So now let's add the new feature age fair ratio. So let's just begin by adding it, age fair ratio, and that will be equal to df.age divided by df and fair. Perfect. Now let's have a little look at how this will look like. df.head, and let's run this code. Right, so now we have the new cleaned data frame. We have the survived, we have the passenger class, sex still there, age fair, sex encoded, so 0 for male, female turns into 1, and we also have the age fair ratio. And this is all the processing that we're going to do in this step. There's definitely a lot more you can do. You can, for example, take out the first letter in the cabin, because the deck that the person resided in is definitely a proxy for socioeconomic status and might help us determine who survived and who didn't. You can also encode the embarked cities to see if people that embarked in certain cities had a higher survival rate. And now let's move on to the load. So what we're going to do here is we're simply going to save this new data frame into a CSV file to be stored on the computer. So let's just first define an output path, and that's just going to be the file name. So Titanic cleaned.csv. Now let's save. So df.save to CSV. We're going to use the output path, and index we're going to put to false. The index.false here basically means that we're telling the CSV file not to save the indexes of the rows, because they don't really matter in this case. And now let's just print data saved. Right, so we run this, data saved, and we can have a look at the new dataset that we just created. So this is the processed Titanic cleaned dataset that we just imported from GitHub, and we have all of the columns that we would maybe want in some kind of machine learning algorithm that would try to predict who survived and who didn't. So this is how you make a really simple Titanic extract transform load code in Python in a notebook. So we just took it from GitHub, had a look at the columns and decided which ones we want to use. Then we transformed them. We got only the ones that we wanted. We dropped the missing ones, and then we created some new columns. And then finally, we loaded it into a CSV file. So if you enjoyed this video, please hit like and subscribe, and I'll see you in the next video.